This video is about the life cycle of stars, which have a low mass, like the Sun. Once a star has formed and become stable as a main sequence star, the remaining stages depend on its initial mass. In this video, we'll look at the life cycle of stars that are about the same size as the Sun. In the core of the star, all the hydrogen eventually fuses into helium. However, the temperature is not high enough yet for helium fusion to start. So, without fusion, there is nothing to maintain that outward pressure. So, gravity takes over, causing the star to collapse. As the star collapses, it pushes the helium nuclei closer together, causing more collisions to happen. This raises the temperature of the star to the point where nuclear fusion can start again. The new burst of energy from fusion causes the outer layers of the star to expand, cool down, and become redder as it becomes a red giant. As helium fuses into heavier elements, the star is once again stable for a short time. Once the helium supply in the core runs out, fusion stops for good, and the outward radiation pressure can no longer keep the star stable. The immense gravitational force takes over and compresses the core of the star. Meanwhile, the outer layers are cast off and form a planetary nebula. So far, we have seen a low-mass star becomes a red giant, and then a planetary nebula. Let's take a look at the final stages of the star's life. The outer layers of the planetary nebula continue to drift into space. In the center remains a small, dense, hot core called a white dwarf. Over time, it releases all of its leftover energy from fusion and fades into a black dwarf. The white dwarf and black dwarf stages are the final two in the life cycle of a solar mass star. As well as learning the different stages in a solar mass star's life cycle, make sure you can explain how fusion influences each stage, and how the two forces acting vary throughout the cycle. Let's look at an example question. The Sun will go through many stages, but spend most of its life cycle as a main sequence star. This is the stable period of the Sun's life cycle. Part A is a 1-mark multiple choice question. Which of the following stages will the Sun go through? The Sun is considered a low-mass star, so after its current stage, it will become a red giant, then a planetary nebula, and then a white dwarf. This means option C is correct. In a different video, we will see that only high-mass stars can become a supernova, a neutron star, or a black hole. Next, Part B asks us to explain what will happen to cause the stable period in the Sun's life cycle to end, for 2 marks. We know that the stability of a star comes from the balance of the inward gravitational force with the outwards radiation pressure from fusion reactions. So, for the 1st mark, the cause of the end of the stable period is due to nuclear fusion slowing down. When you see the command word explain, it usually means you will need to use the word because. So for the 2nd mark, nuclear fusion will slow down because the supply of hydrogen in the core will run out. Then Part C asks us to describe what will happen to the Sun after the stable period ends, for 3 marks. In Part A, we said the Sun will become a red giant, then a planetary nebula, and then a white dwarf. When you see the command word describe, it isn't usually enough to only state the names of the stages. We need to give some more detail about the physical changes that will occur. So for the 1st mark, after the Sun's main sequence stage, the core will shrink and heat up, and the outer layers will expand as it becomes a red giant. For the 2nd mark, the outer layers will cool down and drift away as it becomes a planetary nebula. And for the 3rd mark, once the outer layers have drifted away, a hot, dense core, or a white dwarf, will be left behind. In summary, after the stable period of a low-mass star ends, it will become a red giant. This is when hydrogen fusion slows down and the core shrinks and heats up, until helium fusion can take place. This new burst of energy causes the outer layers to expand, cool, and appear redder. Next, a planetary nebula forms. This is when the helium supply in the core runs out. At this stage, fusion stops for good. The core shrinks again, and the outer layers are ejected into space. A white dwarf remains, which eventually becomes a black dwarf. A white dwarf is the small, hot, dense remnant of the star's core, which becomes a black dwarf once all the energy has been released into space. Don't forget to check out all of our other fantastic revision resources here at Save My Exams.